Welcome to this educational video, where we explore one effective method for clearing radioactive waste. This method is designed to handle low and intermediate level activity waste, not containing difficult to measure isotopes, and have only gamma radiation with energy level between 80 keV and 3 MeV. In the assessment of such waste, not only the radiological properties but also other relevant factors such as chemical and biological safety should be taken into account. This video shows the assessment of a non-infectious waste containing low-mobility iodine-131 isotope. It's highly advisable to maintain a continuous ambient gamma background radiation monitoring and alarm system within the premises. This system serves to keep all on-site workers informed about the prevailing radiation levels. Regular checks of ambient gamma dose rate transmitters with test radiation sources are essential. In the event of an alarm sounding from the system, work procedures should be halted, and a thorough investigation into the cause should be conducted promptly. It's crucial to adjust alarm levels according to the specific technological tasks before commencing any work. The radiation portal monitor installed at the entrance of the assessment site area serves a dual purpose. It can be utilized for both pre-assessment of waste and precautionary measures. Moreover, if the portal monitor is equipped with isotope identification capabilities and detects an isotope that is not expected based on the technology involved, it should undergo separate testing to verify its accuracy and functionality. The use of radiation portal monitor provides an opportunity to establish depth protection or to avoid cross-contamination from other isotopes. The assessment procedure requires the use of personal protective equipment, PPE, as defined in the Workplace Radiation Protection Regulations. In this video, a lab coat, rubber gloves, leg bag, goggles, FFP2 mask, dosimeter were used. The procedure also requires two professionals with at least extensive knowledge of radiation protection. The supervisor must be appointed before the work starts. Also, the person who handles the waste, referred as dirty hands, and the person who handles the detectors and administration equipment, referred as clean hands. Keep in mind that we'll assume the exterior of the waste package being assessed is contaminated. Therefore, it's imperative to ensure proper protective equipment and site preparation before conducting any assessment. Moreover, as we conduct the waste assessment, our goal is to minimize the generation of additional radioactive waste. While working with waste packages, there is a possibility that the packages may become open, increasing the risk of exposure. Therefore, it is also recommended to measure the activity concentration of radioactive substances in the air at the assessment site. This is typically done using a detector that forces the air in the room through a filter. The detector then determines the activity concentration per radionuclide from the contamination captured by the filter. In case of an alarm indicating elevated levels of radioactive substances in the air, the assessment must be immediately suspended, and a thorough investigation into the cause should be initiated to ensure the safety of all personnel involved. Throughout this presentation, we will focus on assessing the simplest waste sample. However, it's essential to note that the assessment process may vary depending on the technologies involved in waste generation. Before proceeding with the assessment, it is imperative to measure the presence of contamination in the work area using a surface contamination meter. If contamination is detected, appropriate decontamination measures should be taken as necessary. To maintain cleanliness during the assessment process, a separating material, such as a foil, should be placed on the clean table. Additionally, sample bags should be prepared in advance for storing smear samples, with each bag individually identified for proper documentation and tracking. Before placing the waste package on the workbench, it's essential to measure the radiation at the bottom of the package. Next, rotate the waste package to identify the point where the radiation level is the highest. Once the highest radiation point is identified, smears samples should be taken from this location. Before sampling, it's advisable to capture a photograph and record the identification of the waste package. For this purpose, it is recommended to use a barcode-based system, which allows the barcode to be easily scanned by a tablet's camera, shortening the time needed for this task. To ensure consistency, a frame with a fixed size should be utilized during smears sampling, and tweezers are recommended for handling the sampling cotton wool. It's crucial to exercise caution to avoid damaging the waste package during sample collection. The material and the size of the sampling fiber must be the same throughout the measurements. And it may also be dipped in solvent before sampling to achieve better smears efficiency. At least 2 wipe samples shall be taken from the same surface and placed in the pre-labeled bags. Moreover, wipe samples should be collected from the entire surface of the waste package as well, ensuring that measurements are conducted in an area not affected by radiation emanating from the measuring bag. If deemed necessary, the entire waste package should undergo decontamination procedures. If the waste package can be repacked, a new protective packaging should be applied to prevent further contamination during subsequent measurements. In case of repackaging, the new waste bag should be reassessed. The new protective packaging and decontamination levels should be specified in advance for each technology. To determine the composition of isotopes and the activity of radioactive material within the waste package, the package should be rotated in front of a spectrometric detector. The size and shape of the package should be taken into account. If the waste cannot hold itself on the measuring surface, the use of a plastic container is recommended. Additionally, a scale is employed to measure the mass of the waste. While a tape measure is utilized to determine its volume. The activity divided by the mass provides the activity concentration per radionuclide. For recording data, an environmentally friendly tablet is highly recommended. Such a tablet can be easily cleaned in case of contamination and offers a convenient platform for data entry and storage. Following the measurement process, it's essential to verify the cleanliness of the measurement site using a surface contamination meter. Before exiting the lab area, it's essential to conduct a thorough check of the body surface, in particular the hands and feet, of the measuring team members using a surface contamination meter. It must be ensured that no uncontrolled contamination can escape from the assessment site. After taking off the personal protective equipment, the contamination of the hands and feet must be checked using a surface contamination meter placed at the exit of the workplace. Prior to utilization, it is crucial to ensure that all scintillation detectors undergo calibration, employing at least one point source, along with conducting a background measurement. Additionally, a comprehensive calibration encompassing full energy, full width at half maximum, and efficiency should be executed at suitable intervals. For dosimeters and surface contamination meters, it is imperative to verify that the detectors have not expired. This entails confirming the measured background radiation and point source response before deploying them. In instances of encountering high background radiation or discrepancies in control measurements, a thorough assessment of both the detector and the surrounding environment should be conducted to maintain accuracy and safety standards. The smears samples should undergo a precise measurement at a low background measurement system, utilizing a spectrometric detector ideally capable of simultaneously measuring alpha, beta, and gamma radiation. By summing the activities measured on the smears samples and dividing by the surface area of the sample, the non-fixed surface contamination can be accurately determined. Once the data have been recorded, the measured activity and activity concentration values should be compared with the levels specified in the workplace radiation protection regulations. And the waste package should be assessed on the basis of regulations. Upon completion of the work, it's imperative to assess the cleanliness of the measuring site. If deemed necessary, Surfaces should undergo decontamination procedures to ensure a safe working environment.